Good morning, everyone. This hearing will now come to order. It's a pleasure to welcome all of you to today's subcommittee hearing. We have an impressive panel of experts appearing before us, and I look forward to a good discussion. Let me get right to the point. I think that today's hearing is one of the most important that this subcommittee is going to have all year. And why do I say that? It's no secret that this nation is wrestling with twin challenges of achieving energy independence and protecting and preserving our environment. These are very difficult challenges, but they're challenges that we have to address, and there are challenges that we have to meet. Every sector of our economy is going to have to play its part in helping to reduce our dependence on foreign energy, as well as combating climate change. We all know the importance of aviation to our economy and to our quality of life, but that doesn't give us a free pass. We only have to look at the recent European moves on aviation emissions penalties to realize what's going on. This Congress will be focused on finding the best path forward as it continues climate and energy legislation in the coming months. This hearing will be the first opportunity for our committee to examine one important option for addressing both of those challenges, namely the potential offered by aviation biofuels. In that regard, we have seen increased attention in recent months to the role that biofuels could play as a future aviation fuel source. There even have been recent flight demonstrations of biofueled aircraft, and we will hear about some of those flight tests at today's hearings. Yet the limited experience to date with the latest generation of aviation biofuels doesn't provide enough information to know what role they will ultimately play in aviation. And that's not surprising. As the Nobel Prize-winning physicist once said, prediction is very difficult, especially if it involves the future. Now, we also don't have enough information on the potential unintended consequences of different types of aviation biofuels, and in particular, their impacts on land use, water use, if they go into widespread production. I called today's hearing so that the subcommittee could start to get some real answers on the outstanding questions that will have to be addressed if biofuels are to play a significant role in aviation in the future. Most importantly, I'd like to find out what is being done by both the federal government and the private sector to address these challenges. We have first-rate R&D capabilities at NASA, the FAA, DoD, and DOE, as well as America's companies, research institutes, and universities. However, those capabilities will not suffice without clear R&D roadmaps, program plans, and resource commitments to guide our efforts. I'm afraid the odds of success will be reduced without an integrated federal-private sector approach to evaluating the potential benefits and costs of aviation biofuels, including a systematic plan to understand their impacts on both existing and future aircraft technologies. We have to quote Yogi Berra. I love a committee with good quotes. You've got to be very careful if you don't know where you're going, because you might not end up getting there. So we need to get there as a nation, and I look forward to hearing from today's panelists about that productive path forward. Again, I want to welcome all of you to this very important hearing, and now I'll yield to Mr. Olson for any opening remarks he'd like to make.
Well, thank you, Madam Chairman, and thank you for calling this morning's hearing. My thanks, too, to our witnesses for taking the time out of your busy schedules to appear before us today. I know that you invested many hours in preparation for today's hearing, and I'm grateful for all of your efforts. While aviation is a relatively small contributor of greenhouse gas emissions, the marketplace compels the industry to continue to invest in technologies that make the system and the aircraft that operate within it more efficient and more environmentally benign, no matter the vast performance improvements that have been achieved over the past couple of decades. Fuel price spikes that occurred during 2008 were a stark signal that if we are to retain a robust and affordable aviation system, we must take aggressive steps to develop alternative sources of fuel. World demand for petroleum resources and production caps imposed by OPEC are again driving fuel prices to higher levels, and in doing so, they threaten our economy and our quality of life. Biofuels present a possible new source of energy that could power our aircraft and at the same time greatly diminish the amount of carbon emitted into the atmosphere. I am optimistic that through cooperative government and industry research and development, the marketplace will be able to develop fuels that will meet these challenges. I commend the work done at NASA, the FAA, and by the private companies, some of whom are represented here today. And I'm hopeful that the good work being done is both widely communicated and adequately funded. In my mind, this kind of research our federal government should be funding, the kind which has practical use for private industry that will eventually benefit consumers and in doing so help to end our dependence on foreign sources of energy. I look forward to hearing your testimony and to our discussion. And please don't think I'm going to be easy on Mr. Shannon just because after only 2 months as a member of Congress, I've already achieved elite status on Continental Airlines. Thank you very much for being here today, Madam Chairwoman. I yield back.
Thank you, Mr. Olson. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I'd like to introduce our witnesses. First up, we have Dr. Jaiwon Shin, who is the Associate Administrator for the Aeronautics Research Mission Directorate at NASA. Welcome. Dr. Lourdes Maurice, who is the Chief Scientific and Technical Advisor for Environment in the FAA's Office of Environment and Energy, and is the Environmental Lead on the Commercial Aviation Alternative Fuels Initiative, or CAFI. Good morning. Dr. Alan Epstein, who is the Vice President of Technology and Environment at Pratt Whitney. Good morning. We have also Mr. Billy Glover, who is the Managing Director of Environmental Strategy at Boeing. And finally, we have Dr. Holden Shannon, who is the Senior Vice President of Global Real Estate and Security at Continental Airlines. Welcome. As our witnesses should know, we will each have 5 minutes for your spoken testimony. Your written testimony will be included in the record for the hearing, and when you have completed your spoken testimony, we will begin with questions. Each members will have 5 minutes to question the panel. And why don't we start with Dr. Shin?
Good morning, and thank you, Madam Chairwoman Giffords and Ranking Member Olson and members of the subcommittee. Thank you for this opportunity to appear before you today to provide NASA's perspective on the emerging use of biofuels for aviation, including agency's current research in this area. Growth in the air transportation system is vital to the economic well-being of our nation. In order to meet the projected growth in aviation, significant challenges must be overcome, including environmental sustainability. NASA is conducting cutting-edge research to dramatically improve aircraft efficiency and revolutionize aircraft operations in the national airspace system, both of which will reduce environmental impact of aviation. Biofuels offer the potential for the significantly reduced carbon footprint over the entire life cycle from fuel production to utilization. Current NASA research on increasing aircraft efficiency and operational procedures, coupled with the use of biofuels, presents a possibility of dramatically reduce the carbon footprint for the aviation sector despite the projected growth. Recognizing the importance of biofuels for the future of aviation, NASA has initiated a modest research effort in 2007 that builds upon the existing expertise in fuel chemistry and processing, combustion and gas turbine engines to address some of the challenges associated with the application of these fuels for aviation. However, NASA also recognizes that the widespread use of biofuels for aviation will require concerted effort by multiple government agencies, aerospace industries, academia, and biofuel producers. The need for a coordinated approach to enabling new fuel sources is highlighted as one of the goals of the National Plan for Aeronautics Research and Development and related infrastructure. While recent successful flight tests have shown the feasibility of using blends of jet fuel and different types of biofuels under controlled conditions, several technical and economic barriers remain for widespread use of biofuels in the aviation sector. The major question related to the production of biofuels is whether they can be made sustainably, economically, and at a scale sufficient to support the aviation industry. Additional basic and applied research will be required to scale up the process for producing large quantities of biomass that are economically viable and sustainable. There are uncertainties related to the application of biofuels for aviation because of the extremely limited amount of testing conducted to date with these fuels. Most of the NASA research is focused on issues related to the application of alternative fuels. We need to study the combustion process using alternative fuels and understand whether the combustor performance is different from that achieved when jet fuel is used. The impact of the use of alternative fuels in aircraft safety is another area that needs further study. Foundational research on the effect of alternative fuels on engine performance and degradation of engine materials is required to identify potential safety issues and develop mitigation strategies. NASA is conducting long-term foundational research to understand the effects of various alternative fuels on aircraft engine emissions. Research includes laboratory combustion testing under controlled conditions and ground engine testing under simulated flight conditions. All of NASA's research efforts on alternative fuels to date have been focused on the application of synthetic jet fuel produced from natural gas and gasification of coal and conversion of the gases to liquid fuel by the Fischer-Tropsch or FT process. Current research using FT fuel is providing valuable insight into emission characteristics of alternative fuels. We're also studying ignition times, flame speeds, and chemical kinetics. These are parameters which affect the design of new combustors. As the second generation of biofuels become available, there is a need for research to understand these parameters for biofuels so that we can effectively design new low-emission combustors that are fuel flexible. The effects of biofuels and engine emissions will also be determined through a combustion of laboratory testing and ground engine testing under simulated flight conditions. In conclusion, NASA participates in alternative fuel-related road mapping and planning activities that are underway, most prominently led by CAFE. We also participate in Air Force-led efforts to develop rules and tools for use in predicting the life cycle greenhouse gas emissions of alternative fuels. And we are on the advisory board of FAA's partner Center of Excellence, which conducts alternative fuel emissions and life cycle studies. We're willing to participate in alignment of alternative fuels activities along with other government agencies, industries, and academia as appropriate. These roadmaps are identifying the research development and demonstration needs and defining the roles and responsibilities for multiple organizations. NASA believes its expertise and research capabilities in combustion, turbine engine performance, fuel processing, materials, and computational modeling can be utilized as part of nationally coordinated research effort to address some of the key challenges that must be overcome for widespread use of second-generation biofuels in future aviation. I'll be happy to respond to any questions you or other members of the committee may have. Thank you.
Thank you, Dr. Shin. Dr. Maurice, please.
Good morning, Madam Chair, Congressman Olson, and members of the subcommittee. I welcome the opportunity to testify today about the ongoing work of the FAA and our colleagues on renewable jet fuels. FAA helped form and is an active participant in the Commercial Aviation Alternative Fuels Initiative, or CAFE. I serve as the environmental lead for the group. Founded in 2006, CAFE is a coalition of airlines, airports, aircraft and engine manufacturers, energy producers, researchers, and U.S. government agencies that are leading efforts to develop and deploy alternative jet fuels for commercial aviation. We know environmental and energy issues will significantly influence the ability of our aviation system to grow. Renewable jet fuels could be the game-changer technology that gets us closer to carbon neutrality. These fuels can not only improve air quality and reduce life cycle greenhouse gas emissions, but also enhance energy security and supplies. And renewable jet fuels are critical to achieving the environmental goals of the next generation air transportation system, or NextGen. Today's hearing is well-timed. Aviation has made enormous progress in the last 3 years identifying and testing technologies for alternative fuels and in progressing toward broad airworthiness certification. We have identified a number of options that can replace petroleum jet fuel without the need to modify aircraft, often referred to as drop-in fuels. CAFE has taken a comprehensive approach to the development, evaluation, and deployment of these drop-in alternative jet fuels. Efforts are focused in 4 key areas: fuel certification, research and development, environmental impacts and cost and benefits, and the business and economics of commercialization. Let me highlight a few key points. The CAFE environmental team has focused on measuring the potential to reduce aviation greenhouse gases using renewable jet fuels. The FAA and the U.S. Air Force are jointly funding the development of a greenhouse gas life cycle analysis framework. We refer to the approach as well-to-wake. We are also assessing the ability of these fuels to reduce air quality impacts. For example, we recently obtained direct measurements that showed significant particulate matter reductions. This is important because 44% of our busiest 50 airports are in areas of non-attainment status for particulate matter emissions. CAFE uses R&D roadmaps to align and communicate research needs for alternative fuels. I should note that CAFE does not sponsor research per se. Rather, we try to ensure a coordinated approach to strengthen each other's efforts and avoid duplication. We've submitted copies of the roadmaps with my written testimony and would welcome your input. With regard to how alternative fuels will actually be introduced for use, the FAA collaborates with ASTM International, the industrial standard setting organization, to perform the technical evaluation of potential alternative jet fuels leading to FAA airworthiness certification. The process adheres to strict rules and standards to ensure safety. We anticipate approval for a generic standard for a range of fuels from Fischer-Tropsch processes, including biomass to liquid fuels, for use at a 50% level this year. Similarly, we forecast approval for use by as early as the end of 2010 of hydroprocessed renewable jet derived from non-food biomass feedstocks. This potential approval relies on recent data, but may also require additional investment in research. A number of significant challenges remain. First and foremost is certification. We believe we have a path for achieving renewable jet fuel approval. However, approval will require significant amounts of alternative fuels and engine tests and evaluation. There can be no shortcuts to safety. Next is the challenge of accurately quantifying environmental impacts. Assessment of both air quality and greenhouse gas life cycle emissions must continue to be timely and thorough as new fuel options emerge. This will also require significant effort and the collaboration of all stakeholders involved. Supporting certification and environmental impacts assessments are a major focus of FAA's CLEAN programs, and we appreciate the subcommittee's support for these efforts. The final hurdle is infrastructure and deployment. The unique combination of dependence on high-density liquid hydrocarbon fuels for the foreseeable future and a very condensed infrastructure, about 80% of all jet fuel used at our 35 busiest airports, makes aviation both difficult and attractive for pursuing alternative fuels. We're convinced that the public-private partnership that CAFE represents will help commercial aviation be a first mover in the deployment of alternative fuels. Madam Chair, members of the subcommittee, that completes my prepared remarks, and I look forward to your questions.
Thank you. Dr. Epstein.
Madam Chairwoman and members of the subcommittee, thank you for inviting me. 50 years ago this January, a Boeing 707 powered by Pratt Whitney engines flew the first transcontinental commercial jet flight in the United States. Since then, our jet engines have improved dramatically to the point where the most modern, pure power engines consume only about half as much fuel as those on the 707. However, no progress has been made on civil aviation fuels. We use the same fuel today as we did in 1959. First, let me address why biojet fuel is important to aviation. We expect commercial aviation to grow at an annual rate of 4 to 5% averaged over the next 40 years. Given a renewal of the public-private partnership in aeronautical research, engine and aircraft designers can continue the 2 to 2.5% per year improvement in fuel economy we've demonstrated over the last 50 years. However, without further action, aviation CO2 would still grow 2 to 3% per year. The only solution is to move to a low-carbon fuel, such as a sustainable biojet. Simply put, biojet converts aircraft to solar power, with the fuel simply serving as a chemical battery recharged by the sun. The many practical considerations of capital, manufacturing, and logistics, combined with the imperative for near-term action on climate change, means that a new fuel should be a drop-in fuel. Drop-in means a fuel that can be distributed and used without modification to delivery channels, aircraft, or engines. And my comments are offered in the context of drop-in sustainable biofuels. At Pratt Whitney, we've been testing biofuels in the lab and in engines. While lab testing is very useful, I cannot overemphasize the importance of full-scale tests. Pratt Whitney has tested biojet blends in a variety of engine sizes, ranging from those powering small business jets up to the Boeing 747. These tests revealed no negative effects on engine operation. Actually, pure biojet was better in that it reduced the particulates emissions important to local air quality. This January, a Pratt & Whitney-powered Japan Airlines Boeing 747 flew with a mix of conventional and second-generation biojet fuel. We saw no impact on performance or engine life. The test is noteworthy because of the varied feedstock used, camelina, jatropha, and algae, which shows that aviation need not bet on a single approach. We are planning an additional test flight next year. Each flight builds confidence. Pratt & Whitney is also leading an international consortium looking at sustainable biofuels as applied to small gas turbines that power general aviation, business, and commuter aircraft. One thing we've learned is that an engine can be designed to reduce fuel consumption if we can be assured that all aircraft fuel was largely biojet. Unfortunately, no such gain can be had from current engines. While we do not expect these fuels to affect the economic life of the 70,000 Pratt & Whitney engines in the field, additional work such as endurance testing is a wise idea. Funding for such tests have yet to be identified. The aviation community is sharing knowledge to certify biojet. This builds on our experience from the recent Air Force program, which certified alternative fuels for energy independence. So where do we go from here? Industry is working together to define appropriate standards, and I expect that biojet can be produced to meet these standards. So biojet can move into service with a few more tests, documentation, and action by the approving bodies, which can be done in the next 2 to 3 years, at which point all you need is commercial quantities of biojet. So the challenges remaining are not in the realm of the propulsion engineer. They belong to the business community, to bio and chemical engineers, to ecologists, and to lawmakers. The growth of the biojet market will depend upon cost and on capital. The cost of the fuel must reflect the value it brings to the purchaser, and capital is needed for biojet production facilities. This is where biojet research can help by reducing both the carbon and the capital needed to produce fuel. Pratt & Whitney is bullish on biojet for aviation. Drop-in sustainable aviation biojet fuels are an excellent idea for the aviation industry, for the nation, and for the planet. Thank you for permitting me to address this important topic.
Thank you. Mr. Glover.
Good morning, Madam Chairwoman and members of the committee. Thank you for this opportunity to testify. The Boeing Company designs and manufactures a range of commercial, military, and space products, and we're the largest aerospace company in the world, employing over 160,000 people, 155,000 here in the U.S. Today, Boeing produces a family of commercial aircraft, all quieter and more fuel efficient than earlier generations. We believe that sustainable biofuels for aviation have the potential for reduced life cycle greenhouse gas emissions and also the potential to increase fuel supply, both important. We have identified 4 plant-derived oils that have very strong potential: jatropha, camelina, halophytes, those things are available in the near term, and algae in the longer term. Aviation quality biofuels derived from these sustainable energy crop sources show significant improvements when compared to traditional sources. This is not your father's ethanol or biodiesel. It's chemically different. Overall, jatropha and camelina studies show greenhouse gas reductions of 60% or more as compared to petroleum-derived jet fuel. Let me make one thing abundantly clear. Boeing has no interest in becoming a biofuel producer. Our goal is to facilitate rapid commercialization of this new industry and capture this opportunity. We are very confident that sustainable sources of plant-derived oils and processing methods can efficiently produce a high-quality jet fuel. We've demonstrated that synthetic paraffinic kerosene made from plant oils can be blended up to 50% with normal jet fuel and operated in a commercial jetliner without modifications. Over the last year, Boeing has conducted 4 successful flight demonstrations with Virgin Atlantic, Air New Zealand, Japan Airlines, and Continental Airlines. During each flight, a single engine was fueled by a blend of traditional Jet A and biofuels. The biofuels were produced by Imperium Renewables and Honeywell UOP. While we have not completed all of our evaluations from these test flights, we found these new biofuels can actually perform better. They have a lower freeze point, better energy density, and no abnormal wear or engine deterioration. Safety has always been and will continue to be the top priority of Boeing. The three biofuel blends used for the most recent flights and engine tests met all ASTM D1655 performance specifications. So what's the path forward? We believe the principal challenges are commercialization, growth and supply of viable feedstocks, and standard life cycle assessment. Our current projections are that with appropriate incentives, market viability could be achieved as early as 2015. Without such attention, market viability will be delayed. As you know, aviation has few options to reduce greenhouse gas emission. Other forms of transportation can use batteries and electric power, for instance. We can't. Aviation must rely on 3 key strategies. Continue to produce more efficient aircraft. Number 2, fly aircraft more efficiently by realizing the promise of the next gen and improved air traffic management systems. And finally, use sustainable biofuels. Boeing urges governments to support commercialization and development of aviation biofuels by creating incentives for energy crop growers and producers of sustainable biofuels, by ensuring greenhouse gas legislation encourages the development of sustainable biofuels for aviation, by creating predictable demand incentives for aviation biofuel and assisting airlines to invest in these new supply chains, by implementing a refund of the aviation domestic fuel tax when biofuel blends are used, and finally by funding rapid development of standard methods for measuring life cycle carbon emissions and sustainability. It's foundational. Boeing's fully committed to working with fuel producers, engine manufacturers, airlines, and government to ensure the earliest development of commercially viable markets for sustainable aviation biofuels. Thank you again for this opportunity.
Thank you, Mr. Glover. Mr. Shannon.
Good morning. My name is Holden Shannon. I'm Senior Vice President of Global Real Estate and Security, which includes environmental affairs for Continental. Continental has a long-standing commitment to providing customers clean, safe, and reliable air service while maintaining a commitment to the environment. Continental is the world's 5th largest airline, serving 131 domestic destinations, 134 international destinations on 4 hubs: Houston, Cleveland, Newark, and Guam in the South Pacific. Along with Continental Express, we're able to carry our 69 million passengers far more efficiently now than we were a decade ago. In fact, since 1997, we've reduced fuel consumption and emissions required to transport a mainline passenger 1 mile by 35%, which has been largely due to our friends at Boeing, a $12 billion investment in new aircraft, and a whole host of electrification efforts on the ground in Houston, Newark, among other things. Today's airplanes are, in fact, technologically advanced. They are quieter, cleaner, and very importantly, burn less fuel. That's why our industry represents just 2% of all greenhouse gas emissions in the United States, despite continuous growth. To give you some perspective, today uses approximately 18 gallons of fuel to carry a passenger from Houston to Chicago, so say 1,000 miles. That same passenger would burn 45 gallons driving. It's a pretty significant difference. Between 1978 and 2007, so say 30 years, the airline industry as a whole has improved fuel efficiency a whopping 110%, resulting in 2.5 billion metric tons of greenhouse gases. To put it in layman's terms, that's approximately the equivalent of taking 19 million cars off the road each year. Airlines, in fact, have a strong economic incentive to reduce fuel consumption and resulting greenhouse gas emissions. Fuel, as Congressman Olson pointed out, has been a very unpredictable part of our cost. It is the most volatile aspect of our cost structure in an industry that really does have historically low returns, razor-thin margins. Fuel costs last year, and admittedly fuel goes up and down, but as a whole it represents 30% to 40% of our cost, greater than any of our employee costs, wages, benefits, pensions, any of our airplane costs, and any of our facilities worldwide. So by far the largest cost. Unlike other sectors of the economy, airlines have no alternative but to consume jet fuel, as one of my colleagues pointed out, but that could change. Because of our dependence on current fuel sources, as well as our commitment to the environment and our interest in using alternative energy, we decided over a year ago to partner with Boeing and GE Aviation, among others, to conduct a biofuels flight demonstration in Houston to help identify sustainable biofuel solutions for our industry. In our case, we used an algae and jatropha biofuel blend, and this, in fact, was a second-generation biofuel that produces more energy than earlier biofuels and does not compete with food stocks. That's a very important point. As a result, we believe it will be more stable and commercially viable as a fuel source than first-generation fuels, such as ethanol, which one of my colleagues referenced as well. The basic problem with ethanol being it just doesn't have enough kick to be carried relative to the weight that we would need it to generate on an aircraft. The biofuel demonstration last January, we believe, was a huge success, and although, as Mr. Glover has pointed out, we aren't completely finished with the results, we think that the results will be very, very positive. Our analysis of the digital flight data recorder and other data found on the aircraft showed us that it performed the same way that traditional jet fuel did, except that during the life cycle, of course, when you're growing plants, we think we could achieve carbon neutrality. The test itself was highly successful, but much remains to be done to meet widespread use. With the help of government and continued coordination of users, manufacturers, fuel suppliers, we believe that as long as an alternative fuel is certified for aircraft use, meets the drop-in fuel requirement, as Dr. Epstein explained, meaning that no engine modifications are necessary for it to be added at any ratio with traditional fuel sources, and can be made available at an economically competitive price, not a small matter, particularly in the case of algae, which of course is still at its embryonic stages of development. And aircraft operators will have the confidence to start using biofuel in the next 5 to 10 years. Continuing this process is a priority. Even though there has been a downturn in fuel prices, fuel efficiency remains a very huge concern for us and for our industry, as well as for our nation. Further reducing carbon emissions and increasing fuel efficiency, of course, is something that all of us embrace. While there is still today a considerable price difference between traditional jet fuel and plant fuels, we have great confidence that that spread will lessen as supplies of plant fuel become more plentiful. The fact that plant fuel can be mixed in with traditional fuel and it can be dropped right into older engines again means acceptance of the biofuel sources will grow in line with supply. Biofuels represent an important tool for the airline industry to reduce their already small greenhouse gas footprint of 2 to 3% worldwide. We'd be remiss if we did not mention that more focus on the potential, the development, and the use of alternative fuels, as well as other available options, which all of us have talked about, such as the proposed next-gen efforts to modernize air traffic control system, which by itself would reduce fuel burn by 12% for our industry, a huge number, that they are collectively far more commercially productive than to consider imposition of some kind of cap-and-trade policy on the airlines, which would further depress an already beleaguered but necessary industry of air transportation as well as the economy. As you probably know, government actions which cap a company's existing carbon footprint can be unfair and certainly don't reward innovative companies like Continental Airlines. At a time when our nation and Congress are focused on financial stability, we ask you to consider that. Again, thank you for the opportunity to testify at this hearing. We very much appreciate your interest in this subject matter. We look forward to working with you, and we're available for questions. Thank you.
Thank you so much. At this point, we're going to begin our first round of questions, and the chair will begin with herself. Again, I want to thank all of you for being here and for the members in attendance. I think you've made a compelling case of the importance of the use of aviation biofuels. Those of us fly every week, we pay attention, and those that don't fly every week but fly occasionally, we realize that getting this right in the future really has a significant impact to all of us, not just those of us in Congress or those of us who pay attention to these issues. But I guess I'd really like to drill down a little bit harder in terms of how high a priority it is for your specific organizations. For example, Mr. Shannon, you said specifically that continuing with the investment of biofuels is a priority. But exactly when does Continental project that it's going to start using biofuels in its revenue operations? And if you could go a little bit more detail in what type of biofuels you really imagine using. In terms of your competitors, can you talk about the sense of how biofuels fit into their plans as well? And so for Mr. Glover and Dr. Epstein, how important are biofuels to Boeing and Pratt Whitney's plans, and what investments are your companies making to actually be able to deploy the technology so that we can, in our generation, our lifetime, really see this as a mainstream form of fuel? And Dr. Maurice, I know that the FAA is obviously participating in CAFE, and I liked your graphic and slide. You didn't completely go into it, but it was impressive to see the diverse group of organizations involved. But in terms of specifically, what is FAA doing to hasten the adoption of whatever biofuels make to really make the most sense for the aviation industry? I mean, you talked about the importance of fuel certification, but what specific plans and resource commitments has the FAA made to certify not just the drop-in fuels, but also the full range of renewable biofuels that could meet the aviation sector's needs? Also, how long are we talking about? And again, how high a priority is it on the list of everything that's on the FAA's plate? Finally, Dr. Shin, your testimony discusses the long-term R&D needs to address some of the important unknown related biofuels, but in terms of the relation to NASA Aeronautics priorities, can you talk about that in terms of the other issues that are facing you and your organization? Why don't we start with Mr. Shannon?
Okay, thank you. Thanks for the promotion, too. I think self-interest is the key to your question. In other words, if biofuels become economical for us, then I think we would embrace them. We feel very good about the preliminary data from our biofuel test. As someone pointed out, the more biofuel tests there are, the less scary the concept for the public. What's beautiful about this technology is that it has enough horsepower, unlike ethanol. It absolutely does not compete with land that would otherwise be used for crops. You can't eat algae. There is no competition in terms of other demands on the product. And I think as soon as it becomes less than 2 to 3 times as expensive as petroleum, I don't think there's going to be an issue because we can add it incrementally with traditional fuels, and we don't have to change our significant 30, 40-year investment in engines and aircraft. So I think it can be very soon, possibly as early as 5 to 10 years.
Thank you. About 5 years ago, we were complete skeptics. We said there's not enough energy content. We were familiar with ethanol and biodiesel and so on, and you can't produce enough of this, and we'd have to modify engines and delivery systems. But we were starting to see some changes and things that caught our attention. And we were looking at the environmental strategy for the whole industry and said, well, we can keep producing more efficient aircraft. We can help improve the operations, the daily operations, but what else can we do? And we really took a critical look at the fuels. We helped get started the CAFE organization to bring more attention to this and find out what can work. And we became complete converts. So we invested our intellectual capital and our convening power to work with airlines and engine companies and the FAA and others to bring this together, get the facts on the table, and figure out the viability. We think we're largely through the first round of viability. And now we're helping airlines and fuel producers and agricultural interests try to put together deals that could end up in commercially offerable product. And we really see the need to accelerate that, and we're looking for assistance from the U.S. government to find ways to help get over those initial capitalization humps, loan guarantees, and other forms of appropriate encouragement to enable commercialization. We think there are a few things that are ready now and things that need some more R&D that will come later.
Pratt & Whitney is committed to environmentally responsible propulsion, which is our business. And I'm speaking as a propulsion guy. Innovation has been the underpinning, really, of U.S. productivity in the last few decades. And this is an area, as Mr. Glover said, where just a few years ago, what's fuel? You know, it's what we pour in the tanks, what we get out of the tank truck. It's always been the same. And then we've learned with the DoD energy independence effort to certify new fuels how to do it. We work with the FAA, NASA, and DoD researchers making our engines and test facilities available so they could come and make measurements. And now, innovation says we've done two things. We've reduced the amount of fuel we need to certify down to 250,000 gallons. Now, that seems like a lot, except the 747 takes about 50,000 gallons to fill up. So it's not all that much, especially compared to the past where we need millions of gallons. The other is we're getting very enthusiastic because these are really engineered fuels, and American ingenuity and engineering says they're better fuels, and if you can tell me that my engine will have those fuels in the future, I can make a better commercial and better military engine, one that will be lighter, burn less fuel. So we're very enthusiastic about it. Nevertheless, Pratt & Whitney and United Technologies doesn't intend to be in the fuel business, but we're responsive to our customers, Boeing and the airlines, and we're enthusiastic about it.
Thank you for your question, Madam Chair. Renewable fuels are very important to the FAA. Environmental stewardship is at the heart of NextGen, and we view renewable jet fuels as the game changer that can really significantly reduce CO2 emissions. As far as what we're doing to hasten the adoption, there's really two areas that we have a role on. First and foremost is certification and qualification, because you could have the best equipment, the producers could be producing the fuels, but they will produce fuels for those people that can use them. So specifically, we have assigned my colleague, Mark Robinson, to lead the efforts to work with ASTM International, and he also leads CAFI's efforts in this area. So we've assigned the necessary staff to steward the efforts and make sure that they're carried out well. As far as timing is concerned, as I noted later on this year, we hope to be able to have approval for a 50% generic alternative fuel made via the FT Fischer-Tropsch process that could be, it could be made from any number of feedstocks, including biomass, so it would be a renewable fuel. Looking further into the future at the hydrotreated renewable jet, which is the process that was used to make the fuels tested by my colleagues, we would look to next year having the results in front of ASTM International to hopefully get that approved at the 50% plan, and then looking to 2013 to having the 100% hydrotreated renewable jet fuel. So I would echo the statements of my colleagues about 3 to 5 years that we could see some significant use.
And
now,
Dr. Maurice, is that effort fully funded at this point?
That effort with the advent of the CLEAN program, which is appropriated for, I believe it's fully funded.
Okay.
And then the second area, which we can get the certification right, but we have got to make sure that we know the life cycle of greenhouse gases so that we do the right thing. And we are investing resources in working with the appropriate stakeholders to make sure that we can measure that right.
Okay, thank you. I know we're over my time, but I'd like to hear from Dr. Shin, so please.
I'll try to be brief. As Madam Chair noted, the value that NASA Aeronautics brings to the nation is conducting cutting-edge long-term research. And we believe that we will continue work with industry and academia and in the whole community to bring these advanced technologies for vehicles and operations and certainly in the safety area. So as biofuels is getting more economically viable, and if it gets certification and becomes another source of aviation fuels, we'll have to consider that in our future technology development. And one of the highest priorities within NASA Aeronautics is to protect environment from aviation and also make the future vehicles more fuel efficient. So if and when biofuels again become commercially viable and also proves all the benefits, then we will consider this as part of the future technology development, not from the standpoint of production of biofuels, but application of the biofuels.
Thank you, Dr. Shin. Chair recognizes Mr. Olson.
Thank you, Madam Chairwoman. And my first question is for Dr. Shin, Dr. Maurice, and Dr. Epstein. And understanding that and you touched on this, Dr. Epstein, in your opening statement, but understanding that the research in biofuel emissions is still in its early stages, do you have a sense yet of the potential reduction in carbon emissions that could be achieved by using biofuels? And if so, what are the biggest unknowns out there?
I think it's important to understand that the carbon that comes out of the tailpipe of the jet engine is exactly the same no matter what the fuel is, whether it's petroleum-based or coal-based or bio-based. The carbon that we save is the front end, whether the carbon is geological mined out of the ground or whether it's been recently extracted by by plant action. And so in agriculture, we use fuel for planting, for harvesting, for processing the fuel. As Mr. Glover said, we need careful documentation as to how much carbon fuel is used in these processes. But think, these are the same things that society is working on to improve. As you go from big diesel trucks to more efficient trucks, as you can think of even electric power trucks and tractors, the entire carbon footprint goes down. So I can see now where for the few fuels that have been studied carefully, the numbers are 40 to 60% net carbon savings. In the longer term, a decade or two, as society moves more towards a carbon-free transportation, that the jet fuel can come down to very close to zero. We're just recycling solar energy that we collect on our farms.
Thank you very much. Dr. Maurice?
Right, that's a very good question. Thank you. We have done a lot of work in looking at the life cycle, and I would say there's no single number. I think Dr. Epstein's 40 to 60% is probably right about the middle, but I would hesitate to put a single number because it's still a very probabilistic. type of answer. And as far as what the largest uncertainty is land use. When we try to allocate different numbers to different parts of the process, that is by far the biggest unknown. We're working hard to try to address that. I might also mention, don't forget the air quality emissions that we are looking at, and that's pretty straightforward because these alternative fuels are naturally lower sulfur, so that intuitively leads to less particulates. And depending on the engine power setting, we have seen reductions from 10 to 70 to 80%, and that's very attractive. Thank you.
Thank you very much for that answer. And Dr. Shin.
Yes, as Dr. Maurice just mentioned about the low sulfur emission and particulates, we have conducted, partnering with Air Force and FAA and a few other partners on DC-8 aircraft that we have at Dryden Research Center. We didn't fly the airplane, but on the ground, we simulated engine power setting like the airplane was flying. And some of the early findings from the test results support what Dr. Epstein and Dr. Maurice indicated. And the full test results will be analyzed, and we are planning to have a workshop in the fall. So it will be very interesting to find out what really what kind of benefit that we will gain out of this. But this is well-controlled test, and it is one data point. So I think nonetheless, it's going to provide a lot of good information.
Thank you for that answer, Dr. Shin. And Mr. Shannon, one question for you. Given that Continental has been very proactive regarding fuel efficiency and environmental protections, what is your airline's position on how the industry and government should move forward regarding the environment? I mean, do you see it as a cap and trade type system as Europe is proposing, or something else?
We really don't see it as a cap and trade solution, and the reason why is because we feel that there are lots of opportunities to reduce greenhouse gases that are available to us today that we're not availing ourselves of, besides the hopefulness of alternative fuels. When you cap and trade, you cap. You're capping something that is commercially important. The airline industry generates a huge amount of GNP, and of course, it's something all of us love. If you cap flights, you're going to see higher prices. You're going to see more limited travel. One of the things we would suggest is encouraging airliners that have old aircraft to think about replacing those engines, replacing those aircraft. There probably isn't a need to have 40-year airplanes flying around when we have really clean airplanes available. The second thing is that we could do things like modernizing air traffic control. That alone, again, is 12% lower fuel burn. That's not a small number. And then finally, we do see that there are lots of opportunities to promote fuels like what we've seen in the last year successfully piloted. So we're here because of our hope that this technology will provide a solution that does not force you and the economy to choose between aviation, commerce, and greenhouse gases in the environment.
Thank you very much, Mr. Shannon, and I yield back my time.
Thank you, Mr. Olson. The chair recognizes Ms. Edwards.
Thank you, Madam Chairwoman, and thank you to the panelists this morning. I live in the 4th Congressional District in Maryland, which is just outside of the District of Columbia, and I happen to live along the Potomac River and, you know, get to experience the planes flying over all the way up the river, coming back again, and dumping fuel and particulates all along our, you know, baseball fields, soccer fields, elementary schools. And so this is a really important issue for us in our in my congressional district and our community, and I think largely, you know, for the environment. And, you know, Mr. Shannon, I almost left, and then I heard the end of your testimony and decided to stay because you said in your testimony, you talked about cap and trade not being a way to go for the industry. There are alternatives, and I want to follow along the lines of Mr. Olson's questioning because I wonder, you're suggesting that there are sort of voluntary things that the industry could do that would move us along the way toward fuel efficiency and using alternative fuels, and yet we are not very far from peak carbon emissions around the world in 2015. And so I'm wondering, from a policy-making perspective, what kinds of incentives can we encourage for the industry? Because if it's not something that says, you got to get there and make the investment, I think that we're going to get to 2015 and we're not going to be, frankly, that much farther along than we are now. And so it's a little frustrating that although your airline may be doing the right things, we can't just depend on volunteerism alone to get us to lower our carbon emissions.
It seems like a really intelligent question, and I don't want to give you a glib answer. Continental really has made it a sort of a part of our value system to have a clean airline. But I'm telling you, I personally feel that self-interest is a huge motivator. And we didn't start off in the early 90s saying we want to be green. Our awareness was raised along with the population's awareness. We were motivated to reduce fuel consumption, pure and simple. That turned into a green philosophy, and we've embraced it in lots of ways that may not be economical in the short term. I think helping us as an industry create affordable alternatives to petroleum is extremely important, to traditional fossil fuels. That singularly will help us. We had a wake-up call this last year. I mean, we really did. We realized that cheap oil, traditional oil, will not last forever. That's a huge motivator. And that day, we don't know when that day will change again. Today, fuel is relatively more affordable. That's a short-term thing, and we're very motivated to get out of this pinch. So I personally feel encouraging us as an industry to set fuel efficiency standards. Again, we have done a lot as an industry, not just as an airline, but also supporting this effort is one of those things.
Do any of our other panelists have a comment?
One thing that's important is the airline industry is extremely capital intensive. New airplanes cost $100 million or more. And a concern of the industry is that regulations, taxes, carbon trading end up removing money from the aviation system that the airlines need to upgrade their equipment. So how do you reduce the emissions in the short run? The answer is, just as Continental has said, you replace your existing older aircraft, and aircraft work for 30, 40, 50 years, with new airplanes. You need capital to do that. So Congress has to consider, how do you capture any revenue that comes out of regulatory actions in a way that feeds back into the aviation system, funding air traffic control, upgrades, tax credits, investment tax credits for equipment, funding for NASA for advanced research. It really is a system that's starved for funding now. And of course, everybody in the U.S. is starved for funding now. But the point is, there shouldn't be extraction from the aviation system into other uses if we want to make progress in reducing our impact on local communities and the planet.
Thank you, Madam Chairwoman. And I would just say, I mean, I think that, I can appreciate the industry wanting to move forward without those kind of regulations. My real question is just, how do we get there? And for those who are not moving in a direction of a greener, more efficient airline, what do we do to incentivize and encourage that? Thank you, Madam Chairwoman.
Thank you, Ms. Edwards. Good discussion. Let me just remind the committee members and our panelists that this is a discussion today on biofuels and aviation. This is not a big discussion on cap and trade or issues that this subcommittee is not faced with. I mean, we have a unique opportunity to hear from 5 experts on what is happening in terms of biofuel development, and I just want to make sure we don't stray too far. We're going to have a lot of time to discuss other issues, but today, if we could just focus on the hearing topic, I'd appreciate that. Mr. Rohrbacher.
Well, you notice she said that right before I got up. First of all, let me commend the chair. This has been a very valuable hearing, and I think you put together a good panel for us, and I've learned a lot. I would, however, on another issue, which has been the current of all this testimony, is that somehow carbon footprints are affecting our climate. Just for the record of the hearing, I have quotes from major prominent scientists from throughout the world suggesting that CO2 has nothing to do with climate change, especially global warming, considering that now it used to be global warming, and because it's no longer warming, now they call it climate change. So anyway, for the record, I would put that in at this point. Let me say you do not have to be someone concerned about what I consider to be a bogus issue, which is global warming, now climate change, to be very concerned about the health-related problems that come with the internal combustion engine and with jet engines, and also to be concerned about the fuel that would be available to our society to make sure that we can have a modern society and meet our needs. So with that, I am very concerned about what you've said, although I disagree with this carbon footprint talk. Let me ask this question. In terms of biofuels, you've made it clear about the carbon footprint. What about pollutants such as NOx? If we were going to go with biofuels for jet airlines, would we then have more NOx and pollutants that hurt human health, or would we have fewer of those pollutants entering the atmosphere? And particulates as well,
okay.
Right.
NASA researchers and DoD researchers spend a lot of time at Pratt Whitney measuring the effects on engines.
Yes.
For current engines, we expect no impact on NOx at all. That is, you get the same NOx out, whether it's a biofuel or a petroleum fuel. If the biofuel is more than 50% biofuel, then we expect a reduction. Well, we don't expect. We've measured reductions, significant reductions in regulated particulates coming out of the engines. So these are both local air quality improvements. In terms of advanced engines, if we knew we had biofuels, we could probably design them to reduce the NOx a little. The problem is that it's tough to do that and have the capability of pouring in any fuel that's available that's important for assuring the fuel supply for the country. I would also point out...
Well, biofuel specifically, does biofuel reduce NOx?
Biofuel has no effect. Doesn't make it better. It doesn't make it worse.
Okay, good. Is that what we found?
I'm going to defer to more knowledgeable people on the panel. Our preliminary data suggests it might go down a little bit, but not significantly.
Okay. Let me just note, I do come from Southern California. We have these airplanes coming in all the time. We are very concerned about the pollutants that are coming out of the airplanes. And I think that what you've suggested today in terms of the efficiency of the engines that we've heard about today and the amount of pollutants that your airline has been able to take out, you should be commended for that. I'm sorry that our colleague has left who wanted to know maybe how to encourage people to invest in new engines that would bring down the pollution level. Maybe we should, and there's the question, are the depreciation schedules for the purchase of new engines, what are the depreciation schedules that we have? If we changed that, I'm not sure what it is. That's why I'm asking, certainly Pratt & Whitney and Continental. Are we now encouraged to buy new engines and to invest in these things that would be more efficient and cleaner? Or could we change that depreciation schedule to give us more of an incentive to do that?
From a corporate side, I think it has more to do with cash investment. Cash is king in this economy, and I don't think it would materially change our profile. We're just very motivated to get our long-term costs down, not just P&L costs, but our real cash-out costs.
How long does it take you to write down a new engine or a new plane?
You know, I would have to get back to you. I'm thinking that somewhere in the 10, 15-year time frame because a lot of that will depend upon the obsolescence of the technology,
Right.
whereas an airplane itself might have a longer life cycle.
I'm just talking about the tax law now. Pratt Whitney, do you have how long does it take if somebody's going to buy a new engine from you? How long before, if we actually let them write it off the first day, you'd have cleaner engines and companies may buy new engines. Am I?
A great idea, but unfortunately, I'm the tech guy, and to answer your question, we need the money men.
All right. Well,
I'm
thank
the
you very
wrong
much,
person.
Madam Chairman. And let me just note that depreciation schedules, tax policy does impact on these decisions. And if we can change the tax law through depreciation schedules in a way to get people to buy newer jets quicker, it's much better and much more effective, as we've heard from Mr. Shannon, than to have some other regulatory pressure being put on them. That's the incentive. That's the profit incentive you were talking about. Thank you very much, Madam Chairman.
Thank you, Mr. Rohrbacher. I'd like to welcome Mr. Bilbray to our subcommittee. Also, let me remind folks we're going to have votes coming up pretty soon. So, Mr. Bilbray.
Yeah, Madam Chair, I appreciate you having this hearing as being sort of a hotbed of biofuel research. San Diego County, we're on top of a lot of stuff. I have to apologize to you, though, Madam Chair, though, you need to, as we talk about mobile sources, and this is a very small portion of mobile sources, we need to remember where we are in the global atmosphere of stuff, that mobile sources, including aircraft, heavy trucks and everything else, constitute 28% of total emissions in this country, 28%, while electric generation constitutes 35%. And of that electric generation, 22% of electric generation is zero emission generation, has no impact on the climate. So when we talk about these things, got to remember, we're looking at research to reduce 28% of the emissions and what technology we may be able to do that. When today, as we sit here, we have the technology to reduce 100% of that 35% of stationary sources for the generation of electricity. And I want to say that because if we sit in this room, the federal government is still buying dirty coal to generate the electricity for this facility, and I hope we can work together to avoid that. So I want to say to those of you there in the aviation, we have a lot in Washington to do to set an example for you rather than just mandate, set an example. Let me just throw one thing out. Somebody brought up ethanol. What would happen to you if we mandated 10% of your fuel has to be ethanol like we've done to the auto industry?
Ethanol would not work in any of the current airplanes without very significant modifications. It would not fit into the fuel distribution system, and you couldn't fly as far on the same amount of fuel.
Because it doesn't constitute the BTUs per gallon that you have with the other.
Doesn't have the energy.
30%. We always say about 1.5 gallons of ethanol to match a gallon of traditional gasoline, let alone the fuel you're having.
It's the energy content as well as the compatibility. It's incompatible with some of the materials.
And I appreciate that. It's incompatible with a lot of automobile operations, too. That's why we can't ship it through our pipelines. We can't use it for refinery. That's why California has determined that it has no net environmental benefit. ARB, who are kind of like experts in this. I bring that out because we got to go back to what we're doing with a lot of this. In fact, when we talk about emissions, Madam Chair, because ethanol, it takes 1.5 gallons to match gasoline, the emissions are per gallon, not per BTU. And that dirty little secret is that we are mandating a use of a product that claims to be environmentally friendly, but in fact, because of its lack of power, actually is a hidden pollutant problem, and that's one of those things I know it's not popular here to bring up, but I want to bring this up. On the positive side of it, though, I mean, let me say the negative, too. We give ethanol a tax subsidy, but we don't give algae fuel a tax subsidy. Does that sound logical to you guys? Go ahead.
Yeah, I think we need to, I would appreciate if there were supportive policy in place for this different kind of fuel we're talking about here. It's not ethanol. It's this hydrotreated renewable jet. It's a different set of molecules. It has the higher energy content. It has the compatibility. Algae is one of the sources that we're working on, very promising, a little more work to do. But there's some other things that are ready now. And with some supportive policy in place, I think we can make it affordable and make it available to Mr. Shannon.
Okay, and now let me clarify. I totally understand why members of Congress from corn-growing states have pushed this. I totally understand it. What I don't understand is why the rest of us who care about the big picture and the environment haven't pushed back to balance it out. I'd have to ask Dr. Maurice, is it in your position with the FAA, have you met with representatives of the Defense Department regarding an initiative to test and certify synthetic fuels, including biomass jet fuels?
Thank you for that question. Absolutely. Within the Commercial Aviation Alternative Fuels Initiative, one of our collaborators is the Department of Defense, and we share data and collaborate on tests. I might also add that I started my career at the Air Force Research Lab in the Fuels Lab, so I also have personal relationships with those folks, so we're working very closely together.
And does the other services besides the Air Force, are they working with things like algae or biomass fuels?
The other, so we do work with some of the other services, but the Air Force is by far the biggest user, so they seem to be putting forth the most effort.
I appreciate it. Madam Chair, I appreciate the chance. I think when we talk about these technologies, I just want to let you know the bad news on this is the fact that industry is looking for places it can build the facility and get licensed. And a sad thing about it is where you've got San Diego County, where we have all this research, this breakthrough, sadly, they've got to go to New Mexico because in California, the government will not permit the construction of the facilities to make the fuel within the decade. And we need to really put pressure on our colleagues in government to help this move along. So I yield back, and I appreciate the chance.
Thank you, Mr. Bilbray. You're welcome to our committee, our subcommittee, anytime. Come back. We still have some time, so I'd really like to kind of drill down again, and I'd like to use the analogy of building a house. If you're the main contractor, you've got to figure out whether or not your electrician's moving in the right direction. You've got your plumber. Of course, you've got the carpenters. You've got a schedule to meet. So in a way, you've got to make sure that everything is aligned. And so just starting with Dr. Maurice, how does CAFE determine whether alternative fuel R&D initiatives by government entities and the private sector are properly lining up? And given that CAFE has no budgetary or management authority, how is it that you're going to ensure that the various initiatives get aligned if they aren't? And for Dr. Maurice and Dr. Shin, who exactly in the executive branch do FAA, NASA, DOD, DARPA, and DOE report to, each as an agency, to determine what efforts are underway right now or being undertaken in the area of aviation biofuels? And is there any individual organization that has a responsibility for the nation's aviation biofuels activities at this point? And if so, who? And if not, are there any plans to create such a leadership position?
Thank you, Madam Chair. I will start with the question on the building the house analogy, which is actually a very good analogy for CAFE because that's the approach that we've taken in looking at all of the various elements. As far as how CAFE goes about ensuring that we're all moving in the right direction, there's two tools that we use. One is this set of roadmaps in each of the areas to make sure that we can figure out where we want to be and what all the activities need to be to get there. The second tool which is recently developed in January is this fuel readiness level scale, which was really patterned after the technology readiness level to really assess where various alternative fuels, including biojets, renewable fuels, are within the scale so that we can figure out what it is that we need to do to move them forwards. You're absolutely right about CAFE not having the mandate and budgetary authority, but I would go back to what Mr. Shannon said, the term self-interest. And I think all of us within CAFE are very, very motivated to make this happen, and it's within our self-interest to make sure that things move forward. For example, in the certification area, we need need data, and our colleagues, Mr. Glover and Mr. Shannon, as they have moved forward planning their flight tests, have collaborated with us so we could define what is it that you really need so we can collect that data. So I believe we are following your analogy of building the house and making sure we have all of the subcontractors moving in the right direction. As far as your second question of coordination, in his testimony, Dr. Shin referred to the National Aeronautics the R&D plan related infrastructure. Within that plan, there's an energy and environment section, which I happen to be one of the co-chairs for, and that is been, again, that is led by OSTP, by the Office of Science and Technology Policy. And we have used that mechanism to look at the efforts at the broad level. As far as is there one particular entity that has charge of everything, I'm not aware of such a thing.
I think as important a topic as this biofuel is for the implication or potential for the aviation sector, I'd like to use another metaphor or analogy that we've been working within government for bringing this revolutionary air transportation system. Some of the witnesses even noted that next generation air transportation system effort. I use that as somewhat of an analogy that for the magnitude and scope of this kind of emerging technology and involving not only government and private sector and also academia create innovative research, I think we can use the committee that Dr. Maurice just mentioned on the OSTP as a venue to facilitate that kind of government-wide coordination and collaboration. And that subcommittee has been in place for a good 3 years, and it has produced that first ever aeronautics R&D policy and also a subsequent plan. So in that plan, as Dr. Maurice noted, there is a whole section devoted to energy and environment. So I think that is a starting point, could be a starting point to provide better government coordination.
Thank you, Dr. Shin. Mr. Olson.
Thank you again, Madam Chairwoman, and I will be brief as we hear the bells ringing. Just one more question for you, Dr. Maurice. I know you're popular today, but I know the FAA and the EPA are working to accurately measure the emissions data associated with the biofuels production and use. And just curious if you've seen any downsides, starting to see any downsides, some unanticipated results of the research that they might emit a greater form of one pollutant or an altogether new type of pollutant compared to conventional jet fuels.
Thank you, Mr. Olson, for that question. We certainly are looking at all potential contingencies. As far as the tailpipe emissions, really do not see anything because the fuels are drop-in other than that change in particular matter. As far as life cycle emissions, pretty quickly we determined that any competition with food sources or anything that might lead to perhaps using rainforest land and such was not a path that we would pursue. And very quickly, CAFE together and all of us individually came up with this concept that we would go after inedible materials and materials that would not compete with food sources or encourage that sort of land use. So that's been the preliminary work, and we're continuing to look at all possibilities. Thank you so much.
Thank you very much for that answer. Anybody else like to comment on the question? Mr. Glover?
I'd actually like to comment on something that hasn't come up, if you'll indulge me.
Fire away.
This is a new industry. This is jobs. This is not only technology and environment, but it's also jobs. It's an opportunity that I hope you recognize and can help us go down the path. We're trying to do our best, and we sure like to work with everyone to get it done.
Thank you very much for that answer. I yield back my time, Madam Chairwoman.
Thank you, Mr. Olson. Following up on what Mr. Glover said, I agree it's jobs, but it's also an ability for us to inspire that next generation. I mean, we spend a lot of time talking about space in this subcommittee and in this room, and kids are much more in tune with what's happening with the environment, what's happening with the planet, and want to do things in a new, innovative way. And so I think in terms of some of the work that we do to try to get more kids active in STEM education areas, this is a really key way. I'd just like to close with one question, which is a broad international question. I know that the European community recently awarded a contract to ONERA, which is a French aerospace research office, to look at all aspects of alternative fuels for aviation. I also know that there is a plan by 2012 to be perhaps taxing our airlines as they fly into Europe. And I know that, what we would do in the United States is one thing, and obviously those that would have our international businesses have another area that they have to focus on. So I'm curious if our witnesses would like to talk about the scope and comprehensiveness of the European community's research plan, and particularly in relation to ours.
For the first 80 years or so of aviation, there was a partnership between government and industry, investing in research where the government and industry shared research investments, and then industry took it to invest in exciting new aerospace products. To a large degree, that's eroded in this country over the last decade or 15 years. And our products are so long that although we have a brand new engine that we're just introducing, it's really the fruits of a NASA investment in the 80s and early 90s. What I see now is that the preponderance of aerospace investment is moving from the U.S. to Europe. And so now the aerospace is the largest manufactured export of the U.S. It may not be in the future. We need the investment. We need the excitement to bring young people in. I see, as you pointed out, inspiring young people. I find it's very inspiring for our older people. It's been astonishing how people come up to me and say, I'm really glad to see the companies doing things to make the planet better and to help do the green. I think the nation has to consider its balance of investments in terms of research and technology. And aerospace, frankly, has been languishing, and we may have a problem going forward in the future. The one other thing I would add is that for emissions and climate, the world and the industry has been very well served by ICAO, the International Civil Aviation Organization, which sets standards for noise and for emissions. The FAA is the representative of the United States. For manufacturers, it tells us what's coming. It lets us plan our products, lets us invest in research so we meet upcoming requirements. I think it's very important that we not let other countries impose standards, but work together with these international bodies in a consortium to understand where we're going and continue to allow us to do this long-term planning. Thank you.
Thank you. If I could just specifically talk about where we're at with respect to Europe on the subject today, biofuels, I think that is an area that we're ahead, and that particular consortium that you noted actually came to us to learn from how we had formed CAFE. So I think that that's an area in which we do have leadership, and I fully agree with you on the inspiration. As 25 years ago, I came to work in this industry to work on alternative fuels for aviation, and hopefully we'll get it right this time. Thank you so much.
Thank you. Well, before bringing this hearing to a close, I want to thank our witnesses for being here today. I want to thank our members, and for Mr. Olson. I think it was a good discussion. The record will remain open for 2 weeks for additional statements from the members and for answers to any of the follow-up questions that subcommittee members may ask of the witnesses. The witnesses are excused, and this hearing is now adjourned. Thank you so much.